All right, see if I can get this working here. So yeah, I think if we look at the course planner, which I, put out where back at the end of September, right? The most recent revision of it. In there, I said that this class has a quiz. Let's see here if I can find it. So, we are currently right here, the 20, I think we're there, right? Wait a minute, I can't do math. I can't do dates. The 23rd, where's that? 21, we're right here actually. This is the day we're at. So we are, pretty well ahead of schedule. And of course I just collected, your mission. So I have down additional examples for next Monday and Wednesday. And then quiz 3 is next Friday. So that would be the 30th. No, we're not going to take Monday off. You guys are funny. Comedians. Now we'll have quiz 3 next Friday. And then we'll have the review November 2nd. And the test will be, that'll be the 4th of November, right? So what I'm going to do is I'm going to go ahead and I'm going to start covering this material down here during these days because we'll have all of today to review the homework. Now, if you have additional questions about the material next week, you can ask them and I'll respond to it. But otherwise, I'm going to forge ahead into chapter 4, and hopefully by the time we get over to here, we'll be done with that material, and then I can spend a day actually reviewing. I already have one day set aside to just review tests 1, 2, and 3, but maybe if I just forge ahead into the new material, we'll be able to have like 2 days where we're looking back over tests 1, 2, and 3 before the final exam, part 1, okay? And I did get confirmation that this is fine to do. The main thing is administration doesn't want us to complete the course and conclude the course before Thanksgiving, which is understandable, right? The course lasts until the final exam, and that's still the case for you. It's just that. What's that? You don't understand it?
So we're taking an online.
Like a Band-Aid, you just want to rip it off? Yeah. What's that?
So we're taking an online exam.
Online final, but the in-class part here is in class. So part 1 is in class on November 16th and 18th. So I'll take 2 class days to do that.
So do we have to come back that 1 week for that?
This is not after Thanksgiving. This is before Thanksgiving.
Oh, okay, gotcha.
Now, after Thanksgiving, no, I don't expect you'll find me here either. So there's 1 day after the final exam, which is on exponential and logarithmic equations, all right, or wherever we get to in the material at that point. Thanksgiving, of course, then you guys go wherever you go, and we're not going to come back, right? So then these days, I'm pretty sure what's going to happen is I'll just have like a Zoom help session on this Monday and Wednesday, most likely during class time. And then the final exam, well, it's supposed to be December 7th, 11 a.m. to 1 p.m. So I will.
Does it have to be so far in December? That's a lot of break time where I'm not doing a lot of math.
Yes, it does. That's what administration essentially said, yeah. There has to be a final assignment due on the final exam day, yeah.
Can you just make it like one problem, and then like we actually like the exam?
Well, I would expect that this, although I have 2 hours scheduled, I would expect that it's more like a quiz.
Okay.
I mean, it is worth 75 points, so you best not ignore it.
Yeah.
Unless you just like, I mean, you'd have to like totally ace the final exam part 1 and have done all the homework with. That is true. That is true.
Proctored?
This is by Zoom, so it's Zoom proctored. You will join. I will send a Zoom invite on the 7th. You will click on it. You will open up Zoom, and there you will find the quiz. Yep.
So whichever one of the final exams that we do online, are they all going to be multiple choice, or we're going to have to write it?
I can't speak to other classes, obviously. Like, I don't know what other professors are doing. But for here, there are 2 parts to the final exam. Final exam, like part 2, which I've just left the final exam here, but that's really final exam part 2. That's worth 75 points. That will just cover chapter 4 stuff, exponentials, logarithms, logarithm laws. But final exam part 1, A and B, is on November 16th and 18th in this room, right? And so it will cover tests 1, 2, and 3. It would be on paper. You'll be sitting probably where you're sitting, taking it. I will collect it at the end. I will be here in human form watching you take the test, the usual thing. And each one of those is worth 100 points. So I'm not giving the entire final on Monday. I'm giving half of it. You will complete your work on that half that day. Then the Wednesday, you will get the other half. You will complete your work on that day. That is true. Because we didn't have enough time to put it on one day here. So, yep.
Part 2, is that going to be
Down here.
including the information from chapter 4, but the
The
it's not going to include?
Right. This one, final exam part 1, does not cover chapter 4. I mean, I will probably be done lecturing on the material for chapter 4 before final exam part 1, but I would not test that on final exam part 1. That will be the comprehensive, your chance to show me that you have fixed whatever it is you misunderstood on tests 1, 2, and 3, and that I should cover those with the grade. You'll have atonement with the grade of final exam part 1. We'll cover those. What's that? Oh, that depends on who you are, but most people have taken 2 tests. So that is not next Friday, but boop, 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 boop. Next Friday we have quiz 3, right? Quiz 3, and then test 3 is the Wednesday after that, so November 4th. So, that will be, when we enter our 2 months of waiting to find out who won the election. We'll be counting ballots in some county we've never heard of before, trying to decide who won. Waiting for the Supreme Court to give its opinion. I don't know. Who knows what will happen? All kinds of fun stuff. All right. So let's get back to let's look at mission 4 then. So thank you for. So what has happened here is somewhat unprecedented in this course, right? I collected your homework, and now I'm giving you a full week to study for the quiz, right? This is what I like to do in my courses, but I just have sort of been behind the 8 ball in here the whole time, and poor planning on my part has made this not happen up to this point. But now you have a week to come to terms with whatever it is you didn't understand here. So let's get started and actually look at these problems. So problem 46. So the discriminant is b squared minus 4ac, right? If it's negative, this means we cannot factor it over the reals. If it's positive, it means that there are distinct real roots. If it's 0, it means you have a repeated root. That's it. So we can always fall back on the discriminant if we're in doubt about how the quadratic factors, right? And we can also always complete the square to see where the vertex is. Like I do that in each one of these problems. See, I complete the square on this, and I get minus 2, 2. See, because it's x. This is 0 when x equals to minus 2. That's where the vertex is. And so minus 2, 2 is the vertex right here, right? And so there you go. That's the graph. Any questions? we can't factor that over the reals, right? Okay. Now this one, we can factor over the reals. Of course, it actually factors to x plus 2 times x plus 6. The discriminant in this case was 16, which is positive. That squares well with the fact that we found distinct real roots of -2 and -6, right? -2 and -6 corresponding to the x plus 2 and the x plus 6 factor. And when we complete the square, we actually get this right here, which shows me that the vertex of the parabola is at -4, -4. About right there. And it's got a positive leading coefficient, right? So it opens up. And I plugged in a couple of other points just to get a sense of the scale, but there it is. This one, the discriminant was 0, corresponding to the fact that, and by the way, just a little trick, well, I don't know, technique, whatever you want to say, but factor the minus out. It just makes your life easier. First, factor the minus out, then work on the problem. That would be my advice, right? So I factored out the minus to start with, and then I can easily see that that's, well, then I completed the square because it's just how I'm wired. And, but that's kind of silly here because, of course, that is x minus 4 squared, right? So completing the square is just factoring here in this case. And great. So that means that the vertex is at 4, 0, which is also where it bounces, right? When the quadratic bounces off the x-axis, has a vertex which is at the x-axis. And it opens down. That's what it looks like. All right, so this one, we're supposed to find a polynomial of least degree whose graph crosses the x-axis at -4 and x equals to 3. And it bounces off the x-axis at x equal to 1. And annoyingly, I told you that the y-intercept was 20. Find the formula. Hey, at least I didn't say find the formula for p of x in standard form, right? At least I didn't do that here. That was annoying elsewhere. But so basically, I put x plus 4, I put x minus 3. That gives me x-intercepts of -4 and 3 where it crosses through, right? I put x minus 1 squared. That's going to make the formula bounce, if you will. The graph will bounce off 1. And so I'm using the factor theorem and also just this observation that when we have an odd power, it crosses. When we have an even power, it bounces. All right? Those are the two ideas I'm using. And also that we have a freedom to rescale the polynomial without changing the x-intercepts, right? And so I also know that the y-intercept is 20, so p of 0 is 20. So I get, 20 equals to minus 12a, which gives me what? Oh, yeah.
Do you take off points if you didn't complete the factors that 20 over 12?
Do I take off points if you didn't do what?
Factors, 20 over -12. You didn't factor.
Oh, no. If you didn't reduce the 20 over 12, no, I don't care about that. That doesn't matter. No, like minus 20 over 12, I would not take off points. That's fine. Yep.
Why'd you flip the sign? That's good with x plus 4 and x minus 3.
Why is the 1 plus 4 and 1 minus 3?
Yeah.
Because going back up to the problem statement, we had it crosses at x equals minus 4.
Yeah.
That's why it's x plus 4. And
But
it
it's increasing.
it's because when, so the factor theorem says that if f of c equals to 0, then x minus c is a factor. So if we have a 0 at 2, that means that x minus 2 is a factor. If I have a 0 at minus 4, that means that x minus minus 4, which is x plus 4, is a factor. So we have to always keep this juxtaposition of sign in mind. And so you notice that the minus 4 and there's a plus 3 here. That's why I have plus 4 and minus 3, respectively. And likewise, this minus 1 because it's at 1. So really, and the logic is that the 0 is when this factor is 0, right? So for x minus 1 to be 0, we need x minus 1 equal to 0, which means that x is equal to 1 when that factor is 0. So yeah, that was that. Now, if you multiply this out, more power to you. I wouldn't count it wrong, obviously. And also, it is possible that we'll find a mistake in this key, right? So if you think something's wrong, speak up. Don't, if you got a different answer than me, maybe you're right, maybe I'm wrong. I mean, that can happen. Why not? Let's see here. So find polynomial which could have a graph which shares the same shape, and X-intercepts is the graph given below. So like, I'm just making some comments. I'm like, okay, so this is a crossing at -6, right? That means I want an x plus 6 factor. This bounce here tells me I want an x plus 2 squared factor. This crossing here tells me I want an x minus 4 factor. And so put it together, I've got x plus 6 times x plus 2 squared times x minus 4. And just one other thing, because we can multiply this by a number, it could be like if this instead looked like this, whoop, like that, if it had that shape, right? It would still bounce and it would still have the same crossings, but it would have a negative leading coefficient, right? But this one is like x to the 4th if you multiply this out plus junk. X to the 4th dominates for x going to plus or minus infinity. So the shape of this is generally like a quartic, and that's roughly what we have overall. So it makes sense. It's got the right global shape, let's say. Is there a question? No? Okay. This one here, again, I want to bounce at 6, crossing at -2, or the -6, and crossing at -2, so x plus 2, x plus 6 squared. And then I got another bounce over here at 4. So put it together, there you go. Now, of course, you could take this and multiply by 7, would still be right. Multiply by 10, still be right. I don't think you can multiply by a negative number, though, because then that would flip the graph over, which wouldn't be the same shape, you know? So, again, this is like x to the 5th, if you think about the global picture of the graph, and that matches the sort of general shape of the picture. Find, so here's yet another, I mean, if you, so I think I gave you enough of these, right? So here we have a crossing at 7 and at -4, a bounce at 0, a crossing at 4, so I have x plus 7, x plus 4, x squared for the bounce, and x minus 4. And there you go. And again, this is x, this is actually a 1, 2, 4, again, it's like x to the 5th, so it's got the right shape. I didn't make a comment, I'm getting lazier, sorry. Now this one, nah. This one was unpleasant. So I tell you that on the one hand, the polynomial can be expanded like so, right, with the coefficients. I tell you that the coefficient of x cubed is 4. I told you the zeros of the polynomial were -2, 0, 1, and 3. And so by the factor theorem, that puts an x plus 2, an x minus 1, and an x minus 3 in the formula for f. But the thing is, f is quartic, right? So all that leaves left over is a scale factor, right? I can't have another factor in terms of x, otherwise you'd multiply it out, you get something larger than order 4, which would not be consistent with what's given, right? So we're logically forced to say f of x has to look like that, given the data that we're given. And then I multiplied it out to get this. And then if we say this is equal to that, well, the thing is there's a 4 right here, and there's a -2a over here. So that means that -2a must be equal to 4. This is called equating coefficients. For those of you who go on to take Calculus 1 and eventually Calculus 2 here, equating coefficients is an important idea for something called partial fractions. But anyway, that gives me a equals -2. Then I plug it back in here, and either you can write the formula like that. And since I didn't say find the formula in standard form, right? So we could leave the answer like that. That would be fine. But if I actually put it back into standard form, there it is. So she was right.
Yeah, so I was trying to go.
Who-
After I found
who-
the figure two, I thought you had to do a lot more.
Who got one more point on the last test?
Say again?
Sorry. That was not on purpose, but it's hilarious for the current conversation. No, you're.
I thought you had to do more with just that A.
Oh.
And I was trying to, I sat there for like a good 10 minutes when she walked in and was like, no, that's just it.
I see. I've had that experience before with other things. I was doing junior level homework once, and I had this problem. I was supposed to differentiate this formula, and I was working with my friend. I call him Paul. Sometimes I call him Somber Paul to distinguish from Crazy Paul. And we were both starting the homework problem same time, and then all of a sudden Paul was done and like working on his Zeppelin song. He's always practicing learning some Led Zeppelin song on the guitar. I was like, how's he done already? I was still differentiating like mad. And then he's like, didn't you use logarithmic differentiation? And I'm like, what's logarithmic differentiation? And then I was like, oh. Anyway, I don't know why your story makes me think of that, but it does. Okay, so problem 52. Minus 2 is a 0 of p of x. Show that minus 2 is 0. So what we have to do, well, there's various ways you could do that. One way would be to plug minus 2 into this and show that it gives you back 0, right? I did not do that. In fact, I think I was supposed to do that here. I think my solution's incomplete. Sorry about that. I think I just glossed over that when I was making my solution. So my solution really should also have p of minus 2 equal to what? Minus 8 plus what? Plus 8 plus 18 minus 18, which of course is equal to 0. All right.
Show that negative 2 is 0. You did found all of 0.
That is also true. I mean, I'm quibbling here. I mean, if I show x plus 2 as a factor of it, then by the factor theorem, that's also shown that minus 2 is a 0. So, like, I don't think I'd take off points if you guys hadn't done that. It would be a natural thing to have done, is just to plug it in and to show it works out to 0. And I'm annoyed I didn't do that on my solution. But I did follow my advice to do factoring by grouping, which worked out pretty nice here, right? X squared times x plus 2, and then minus 9 times x plus 2. So x squared minus 9, which then factors to x minus 3, x plus 3 times x plus 2. And there you go.
Would you have done it by synthetic division?
I couldn't. I don't know synthetic division.
No?
Nah,
The one where you put like x plus 2.
don't believe in it. I like my division to be real. I wanted that synthetic division made in China. Sorry.
Oh, look, there it is.
It's unnecessary. No, I do long division because synthetic division is limited to just linear factors. And yeah, oh, this one, yeah.
I thought that's what we call it.
Oh, synthetic division is this thing where you make just a stack of numbers and you do some kind of algorithm.
Like that, like right there.
Yeah, this is what I do. This is just a quick notation for repeated subtraction. I mean, I can prove that this is true using something called the Euclidean algorithm. I mean, using well-ordering principle to motivate Euclidean algorithm. I mean, this is something we prove in abstract algebra. The synthetic division thing, I don't know, I can't get into it. All right, I digress. But you know, teach his own. Anyway, so the answer to this is nah. X squared plus 3 is not a factor of f of x. When you divide that, I get this remainder. So I think the answer is no. It is not a factor. To give further evidence of that, remember the result I shared with you guys? If an irreducible quadratic is a factor, that means there's a corresponding complex 0. So another way you could have checked it without doing long division is you could just try plugging in the corresponding. So if I had x squared plus 3 as a factor, that would mean that when this is 0, that should make the polynomial 0, right? So when is this 0? This is 0 when x is equal to I times root 3. Plus or minus that, actually. So if I could plug in I times root 3 into the polynomial, and I got that it was 0, then great. That means x squared plus 3 is a factor. However, when you plug in I times root 3 into the polynomial, you get this, which works out to 9 minus 6 plus 3i root 3 plus 10. Nothing cancels this. It's non-zero, not a 0. Therefore, by factor theorem in the complex version, by the complex version of the factor theorem, not a 0. But this up here is what I expected you guys to do. I'm just mentioning this down here as just a, for your information kind of comment. Is x minus 1 a factor of f of x? No, again. Nope. The remainder is 12. And that's not an accident. When you plug in f of 1, right, another quick way to check if x minus 1 is a factor is just to evaluate f at 1, right? And if f of 1 is non-zero, then it's not a factor by the factor theorem. F of 1 is 12. Of course, that's the remainder, right? This it does illustrate the remainder theorem. So anyway, yeah, not a factor, not a factor. This one, on the other hand, does have a factor. F of 3 is equal to 0. And I'm asked to factor it completely over R. Now, this one, I decided factoring by grouping was a nice strategy because I could just see the x minus 3 popping out, like x to the 4th times x minus 3, minus 2x squared times x minus 3, and this minus 3 times x minus 3. Of course, if you didn't see that, I would recommend long division, or other people might recommend synthetic division to see the cofactor of x to the 4th minus 2x squared minus 3. Now this factors into x squared minus 3 times x squared plus 1, which then further reduces to x minus root 3, x plus root 3 times x squared plus 1 times x minus 3. So there you go. That's completely factored over the reals. Any question? Sorry, I left my whiteout marker at school. Anyway, here, like it's bothering me, but anyway. Just white it out up there? Yeah. Yeah. Thanks, Rudy. Okay, so 3 plus 2i gives me an x minus 3 squared plus 4 factor. 7 minus 3i gives me an x minus 7 squared plus 9 factor. I'm told it's degree 4, so that's all I need, times a constant, right? And the y-intercept is 10, which tells me p of 0 is 10. P of 0 is also a times 13 times 58, which I think is 754a. So a is equal to 10 over 754, which means p of x is this monstrosity, which if you wanted to write it, I'm fine with this as an answer. Technically, this is the answer because this is in standard form. Yeah. Okay, moving on. This one here, x to the 4th plus 7x cubed plus 19x squared plus 23x plus 10, factor completely over R. I give you, see the cool thing is when I give you a complex 0, that tells you a quadratic factor. This is very, very helpful because that means you can cut down the degree of the problem by 2, right? If you can factor out a quadratic and you start with a quartic, that means all you have left is a quadratic. And we can factor any quadratic, right? So, minus 2 plus I gives me an x plus 2 squared plus 1, which is x squared plus 4x plus 5 factor. And so I do the long division, like so. I get 0. That's good. If I didn't get 0 here, something is amiss, But I do get 0, and so I'm left with this is the factoring of f of x. Now the x squared plus 4x plus 5 is irreducible, but the x squared plus 3x plus 2, well, that factors to x plus 1 times x plus 2. So there you go. This is f of x completely factored over the reals. This was over the reals, right? Okay, good. State the rational roots theorem in your own words. I mean, I guess I really can't count this wrong in some sense. Like, I mean, how'd you put it? Does anybody have an answer here other than mine?
Look at my paper. I can tell you, but I forgot.
Well, here's my take. Possible rational zeros for a polynomial are found from ratios of the factor of the constant coefficient and the leading coefficient. Oh, really? I'm very gullible. Don't do that. Let's see here. So I think I almost solved this for you guys in class, but just for the record, plus or minus 1, plus or minus half, plus or minus 2, plus or minus 4, plus or minus 8. That's the complete list for the rational zeros of this guy. And problem 60, that was supposed to be a 2. My apologies. If that's 3, it's not nice, probably. But that's supposed to be a 2. And if it is 2, you can check that P of 1 is 0 and P of 2 is 0. And actually, once I got that, once I knew that P of 1 and P of 2 were 0, the thing about 10 is it's the product of the roots. So if 1 times 2 is 10, that means product of, if you think about it, it's minus the product of the roots. But anyway, explain my logic to you. If you have x minus r1 times x minus r2 times x minus r3, right? Then this is x cubed plus stuff minus r1, r2, r3, right? So if I think about that formula, if I already know that one of the roots is 2, one of the roots of 1, one of the root is 2, I know that when I multiply them together, I get 10, right? That forces me to put minus 5 as the other root, because minus the product of the 3 roots has to be equal to 10. That was how I figured out minus 5 was the other answer, once I knew these 2 were the answer. I think that's an idea I haven't shared with you yet. But anyway. Also didn't write it in the solution because I was out of space. But there it is. X minus 1, x minus 2, x plus 5. That's it. So, and again, yeah, sorry about that typo. I will be grading this very generously because of that typo. That was give a bonus. Yeah, we'll see. Let's not get crazy. Now, so this is plus, minus, minus, minus. So you change from plus to minus once. When we look at P of minus x, we get plus, 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 minus. So there's one variation, and Descartes' rule of signs then implies that this polynomial has one positive real zero and one negative real zero. That's it. If you had like 3, it could be 3 or 1, but when it's just 1, it's just 1. So anyway, again, this is the last time you'll see Descartes' rule of signs in this course. This is not on quiz 3 nor on test 3. I ruled it out for the tested material. There's just not enough problems on it. And I would have to spend a lot more class time to do it justice, and I don't think it's that interesting for this class, so I'm going to go on. You either? Hey, watch it. No, just mess with you. So complex numbers, we have x minus 2 squared plus 1. That's from completing the square. And then that factors to x minus 2 plus I, x minus 2 minus I. That's how you do that. This one, sorry about the 4. That was supposed to be a 5. If it is 4, this is how that factors. Ew. On the other hand, if I had put a 5 there, then x to the 4th plus 5x squared minus 36 is x squared plus 9 times x squared minus 4, which factors nicely to x plus 3i, x minus 3i, x minus 2 times x plus 2. Seems like it got cut off in the scan. Sorry about that. C is easier, right? That's x squared times x squared plus 1, which is x squared times x minus I times x plus I. So this one, you factor x squared minus 4. You factor that. You square it. And then you group terms. So like I've got x plus 2, which is one of them. I got 3x minus 2 factors, so I get x minus 2 to the 3rd power. and I've got x plus 1 squared. So the multiplicity of minus 2 is 1. The multiplicity of 2, speaking of the 0, is 3. The multiplicity of minus 1 is 2. Or, of course, you could say the multiplicity of x plus 2 is 1. The multiplicity of x minus 2 is 3. The multiplicity of x plus 1 is 2. That would also be a good way to talk about it. So multiplicity is just the number of times the thing is repeated. All right? This one here, I said find the x-intercepts and y-intercepts. So x-intercepts come from numerator equal to 0, and the y-intercepts come from f of 0, right? So x-intercepts are x equals to 2, x equals to minus 1, and the y-intercept is 1/3. It seems too easy, doesn't it? Look at all that space.
A lot of those on the test.
A lot of those on the test. And this one was weirding out the tutors. The tutors wanted to make this more complicated, I think, because it really is just equation for the vertical asymptote, x equals to minus 8, x equal to 12, and the horizontal asymptote is y equal to 5.
I thought we had to do a whole polynomial based
I don't think I said that. I said write the equations for each horizontal and vertical asymptote.
I tend to just glance over the questions sometimes.
Oh,
So you just needed to draw the asymptotes?
I didn't even say to draw the asymptote. I said find the equations for the asymptotes.
No, because I just wrote some lines on there and you're like,
So you just like filled in the dotted lines, like traced over them, or?
oh, they're already there. Okay, never mind. No, then that's a different problem.
Yeah, I think, yes.
And Jacob, here you go.
Yeah, you guys crack me up. Let's try to finish this thing here. So this one has, this is a very good problem. It has everything interesting about graphing rational functions, and it's not super complicated. It has a hole in the graph at 1, it has a vertical asymptote at minus 2, and it has an x-intercept at minus 5, right? And so to find out where the hole is, we look at the reduced function, which is x plus 5 over x plus 2. We plug in 1, we get 2, so there's a hole in the graph at 1, 2. The y-intercept is 2.5. It's got a horizontal asymptote of 1 because the leading coefficients are 1 and 1, and the degrees are equal. And so put that all together, I also figured out a few more points down here, and I got something like that. So hole in the graph at 1, 2. And I figured out the values of the function at like minus 8 and 4 and 8, just to add some kind of clarity to it. We talked about this one for a while already, I think. I think I might have missed something when I talked to you guys about it. I don't remember. But when I checked this, when I looked at this problem with the other section yesterday, I found out that there's an x-intercept hiding. And the x-intercept, you can see if you make a common denominator in this case, like that, and like convert it to a polynomial over polynomial formula, if you look at this function, the numerator, call that g of x, you can check out that g of 0 is 29, but g of 1 is minus 2, which by the intermediate value theorem means that there's a 0 for this rational function, somewhere between 0 and 1. I would have missed that if not for using Desmos in class yesterday. That's why I warned you guys that this problem is like fussy and really inappropriate. So yeah, the thing was I didn't realize that it crossed back down through the x-axis last time I talked to you about it, I think. So I might have drawn a wrong graph in here. I can't remember if I actually graphed this one or not in here. I may not have. I don't remember. But this one's picky. So like this, if I was to ask this question on the test, it would be like the bonus question. You know, this would be like on the border of what I think is possible for people to do during time pressure in this class. And that's debatable. This is a difficult problem. Finally, this one, you can factor by grouping, use the sign chart, that's your answer. This one, make a common denominator, identify either the numerator 0 or the denominator 0. those are places where your sign can change, so that gives you this answer. I think I talked about this one, but it might have been the other section, sorry. Anyway, so f of x greater than g of x gives me this quadratic inequality, which I can use a sign chart again to find out the solution is, minus infinity to minus 2 and 5 to infinity. And then finally this one, again, factoring sign chart, I get 2 disconnected intervals, minus infinity to 1 and 1 to infinity for the domain. But the last about 4 problems, the idea of all of them is to identify the points where the expression's either undefined or 0, put those on a number line, and then test points in each subinterval to decide the inequalities. So,
I have a question about the
yeah. Uh-huh.
If you plug in negative, so it can be equal to 0.
Oh,
But if
yeah.
it's equal to 0, it doesn't line up.
So,
It may not include.
you say not included, fine. So, I mean, I was saying, like, this is debatable depending on what you mean by above. So, strictly speaking, I tend to think you're more right. I should probably omit the minus 2 and 5, but I'm not going to, yeah. Some people would say that a constant function is not increasing. I think it's kind of the same issue. Other people say a constant function is both increasing and decreasing. That's the kind of question where, yeah. Anyway, thanks guys. Have a good weekend. And remember, Monday we start when?
We didn't play with the class.
You're fine. When do we start Monday? 12:30, right?